So welcome to our first lesson of calculus. Okay, so calculus, what happens there is that it literally is a topic that brings everything, like all the topics that we've covered so far, that you cover over the course of your life, especially with functions and graphs. It brings them together. It ties everything together. You actually already know the basics of calculus. You might have heard the word derivative. If you didn't, it's okay. You have heard of the word slope, right? So all a derivative is a slope. In IB math, they also call it gradient. You might have heard it called as a rate of change, so change in y over change in x. You might have also heard it as the formula y2 minus y1 over x2 minus x1, okay? So that's all a derivative is the slope of a line, okay? Integrals, all that is the same thing as area. So it's area under some part of either a curve. So area under a curve is what the integral is. Okay, so derivatives is slope and integrals is area under the curve. All right. All right. So we kind of just gave an idea of derivative already, right? It's the rate of change. It's how one variable changes with another. So how does it's always y on top of x, right? So it's change in y or derivative of y over the change in x or the derivative of x, okay? And derivative again is gradient, which is the same thing as slope. You already know how to do this, right? So for example, if you have this line right here, we can see that our slope is positive because we are walking like up a hill. So let's just say you have a line like y is equal to, let's say 2x plus 3, right? Our gradient or our slope is 2. So that means that for every 2 points you go up, you go 1 over. Every 2 points you go up, you go 1 over. And you can see that this slope or this line right here, the slope of this line is the same on any points, right? You can find the slope here and here. That'll be the same thing as here and here, let's just say, right? Or even from here to over here, okay? So the slope is going to be the same regardless, okay? The y-intercept is where it crosses the y-axis, so that is this number right here. So this is our y-intercept or our b, okay? All right, so you already know how to find derivative, but it would be easy if it was just a straight line, right? But because the gradient is constant, so the derivative is constant, okay? If the slope is the same on every single point of the line. All right. But what if you don't have a straight line, right? What if you have something that's like a curve like this? So if you are looking for a curve and you're looking to see where the what the derivative is or the gradient is or the slope is, it can kind of make sense that if you are at this point in the hill, right, where this dot is, that if we draw a line that is a tangent line like this right here, we can see that that part of the hill is flat, right? So here the derivative is equal to 0 because we are not going up or down a hill, okay? Whereas here, we can see that if we draw a tangent line, something like that, we can see that this slope of this line is going to be positive, okay? Whereas over here, if I pick this point, the slope would be negative because we're going down the hill. Here it's flattish, so the derivative is 0. And over here, the derivative is going to be positive, right? Because it is a steep slope, okay? So up a hill, the derivative is positive, and down a hill, the derivative is negative, okay? And again, derivative is just a slope, okay? So the important thing is, where do you find the derivative? Like at what point on the curve do you find your derivative? So that's what calculus is. Calculus is, okay? All right. What's an integral? An integral is just an area under a curve. So if we have this line right here, which is y equals 2, f of x is the same thing as y. So if y equals 2, we have this line right here. And if we say, hey, what is the area under the curve between x equals 0, which is this origin, and x equals 3, which is this line right here, all we have to do, we can see that this is a rectangle, right? So how do you find the area of a rectangle? Area is equal to base times height, right? Or length times width, same thing. So our base here is 3. So it's going to be 3 times, and our height here is 2. So 3 times 2 is equal to 6. So the area of this curve right here is equal to 6 units. Okay, not so bad. But what if you don't have a straight line here? What if you have something that's like a curve? Okay, how do you find the area under that curve? Okay, that's what we're going to be doing. And there's definitely some tricks for that that we're going to definitely learn. So it's actually not as hard as it might seem. But I'm going to ask you to go ahead and just take some notes, and we're going to go ahead and process this. All right, so there are tricks to learning this, but let's just say we have a line and it looks something like this, like a little bit of a curve. One way to go ahead and figure out the area under this curve, let's just say from, from 0 to this point right here, let's just say it's 5. One way to do this is by drawing a whole bunch of like smaller, what is that? By drawing a whole bunch of smaller rectangles. Right, so that's a rectangle, smaller rectangles, right? So one way is to draw a whole bunch of smaller area rectangles, find the area of each of these, and then add them up. So what calculus does, and again, forgive my horribly shaped rectangles, but one way to do this is to look and see if we could draw smaller rectangles and find out the areas of all of those. That's one way that we can find out the area under the curve. Or you could go ahead and take rectangles, and instead of underestimating, we can kind of like overestimate and draw rectangles kind of like this, right? And go, okay, hey, that might be a closer approximation, and find the areas of all of those, but that would take a lot of work. Okay, this is again an overestimate of what it is that we're looking to find, which is the area. Another thing that people might do is say, hey, what if I don't draw rectangles? I went ahead and draw like little trapezoids. Okay, so find the area of that, uh, draw this down, and again, right, that's another way that you could do this. And again, is the closer these rectangles are to each other and the smaller they are, and then adding them up accurately will give you a better idea of the area under the curve. But like I said, the calculator does allow us to find out this area under the curve pretty quickly, as long as you know what the equation of this line is. Okay. All right, so this example that we're going to do right now ties in the basic concepts of calculus, which is finding the derivative at a point and then finding the integral or the area under a curve between 2 points. Okay, so let's go ahead and do the first question first. So it's asking us to find the derivative at x equals 2. So x equals 2 is right here. And basically, we've done this since like probably algebra 1, so we're looking for the to find out what the slope of this line right here is. So this coordinate here is 2 comma 2, and I can see that 0 0 is another coordinate that is along this line right here. So I can find out my derivative or my slope, right? Y, here's x1 y1, here's x2 y2, and all I have to do is plug this in, right? So 0 minus 2 all over x2 minus x1, 0 minus 2. And I can see that when I do this, I get negative 2 over negative 2, which is equal to positive 1. So my derivative or my slope at 2 is 1. My derivative at x equals 0, let me just go ahead and change this color. Sure. So if I look over here, we kind of talked about this with the line, right? I can see that this is a flat line, so my slope looks like it's going to be 0. But let's go ahead and prove that, right? If I have this point right here, which is 6 comma 3, and I'm looking to find out what the slope is at that point, I also need to pick another point along that line, which is right here. So this one right here is 5 comma 3. So if I use my formula again, right, y2 minus y1 over x2 minus x1, to find my slope here, I have x1, y1, x2, let's say y2. So 3 minus 3 over 6 minus 5. 3 minus 3 is 0 over 1, which is equal to 0, right? Which makes sense because this is a line that is going flat, okay? So right now we've just found the derivative of at those 2 points. And now what if we're asked to find, let me just go ahead and erase this. What if we're asked to find the integral or the area under the curve from 0 to 8, okay? So let me just enclose this from 0 to 8. So here, this point right here, well, I can see that this looks kind of like a trapezoid of some sort. I might also be able to split this up and say, okay, hey, this is a triangle and a rectangle. So let's see if we can find out the area of those. So the area of the triangle is going to be 1/2 base times height, right? So here's my base, which is 3. That's 3, and my height here is also 3. So I have my area of my triangle is going to be 1/2 3 times 3. So that's 9. Cut in half is 9 halves, or 4.5. Okay, so this right here, this area is 4.5 units. And then if I want to go ahead and find out the area of my rectangle right here, so area of my rectangle is going to be base times height, or length times width, whichever one you'd like. So my base here is from 3 to 8. So this distance right here is 5, and my height again is 3. So I'm going to do 5 times 3, which is equal to 15. And then to find the area of the whole thing, I have to add those two, right? So 4.5 plus 15 is 19.5, okay? Again, units is for the area of the whole measurement, and I've just found out the integral between those 2 points, okay? Pretty straightforward. That's the concept of calculus, is finding integrals, which is area under the curve, and derivative, which is slope. All right, so the next part is to be able to speak this language is to learn how to write different like letters of this language, right? So derivative, just to refresh our memory, is gradient, as the same thing as rate of change, change in y over the change in x. So some ways that you can write the original function is like y, and its derivative is y prime. Okay, we've done this a lot even through like geometry, when you take a shape and then translate it, let's just say, or move it or reflect it. Now the new image of it is like a prime or b prime or whatever it is. Another way to write your function is you can have something called dy dx, which is dy dx, which is how delta y over delta x, right? That's the change in y over the change in x, which is called rate of change, okay? So that's another way that you can notate derivative, and that's when the original function is y. Another way that you can notate derivatives is if we have f of x, the derivative of f of x is going to be f prime of x, okay? So this is helping us to start speaking the language of calculus, all right? You could also see this in like physics, let's just say, so derivative, how velocity changes with respect to time. So that can be change in velocity, so dv over with respect to time, so we could say dv dt, right? Is a way that we can notate that. How cost changes with the number of products sold, so we could say dc over the number of products sold. We could say dx, right, if x represents the number of products that are sold with that. So you can find a rate of change between any two variables, okay? So it's basically the average rate of change or the instantaneous rate of change, okay? You've done this ever since like middle school, right? So yeah, person A works for 13 hours and earns 94.25. How much does this person get paid per hour? So to find out that, you could do 94.25 divided by how many hours they worked, right? And that's a simple thing to put into the calculator. Right, so when we divide that, we get that person A makes $7.25 per hour, whereas person B works for 19 hours and earns 195.70. So we just divide that and we get 10.3 or 10.30. So who has the better rate of pay, right? Who gets paid more? So we can see that person B gets paid a higher rate um, than person A, right? Almost $3.05 more, okay? So that's how calculus comes in handy. All right, so the last thing I want to show you before we do any problems is if we start with a function, so y equals x squared, you can just go ahead and plug numbers in here. So I had x is 1, so 1 squared, 1 times 1 is 1. If x is 2, 2 times 2 is 4. So I just went ahead and plotted those points, right? 1 and 1, 1 and 2, 4. And then if I said, okay, we want to find the derivative of y equals x squared at this point right here, I just want to show you how to do this in the calculator. So you hit math, and option number 8 is something called derivative and deriv. So we're going to hit option number 8, and then it asks us, okay, what are our variables, right? So we have f of x, so we're going to find d dx. I'm going to go here and I'm going to put the function, which is x squared, so x squared, and I'm going to find the derivative at x equals 1, and then I just hit enter in my calculator and it gives me 2. So it's telling me that the tangent line right here, okay, the slope of this line right here is going to equal 2. So d dx at x equals 1 is going to equal 2 is what the calculator just gave me. All right, so we're going to go ahead and try some practice problems. There are definitely tricks to make this a lot easier, but we're going to go ahead and get started on some practice problems, right? Awesome. All right, so for this problem, all I did is I went ahead to y equals and I typed in my function exactly as they gave it to me. And it tells me that I have to sketch this from 0 to 6, okay? So I went to my table right here, and here's my numbers. These are in fraction form. To graph them, it might be a little bit easier to put them as decimals. So I'm going to hit mode. I'm going to go down, and again, you should not just be sitting there watching me do this. You should be doing this on your calculator. Yeah, so we want to go ahead and change our answers. We want to put it in decimal format, so that way I might be able to graph it a little easier. So 0, 0, that's easy, right? 0, 0. Okay. For the next one, I have 1, which is and then 0.8333. So 1 and 0.8333 is going to be somewhere a little bit less than 1, so I'm going to go somewhere right about there. Then I have 2, 2.6, bad numbers, 2, 2.6, right? So that's going to be around, you might be a little bit more accurate than me, but 2.6 is going to be a little bit more than half, so somewhere around there. And then I have 3, 4.5. So 3, 4.5 is going to be right there around 4, 5.3, 4, 5.3. Okay, somewhere around there. 5, 4.1. So it's going to come down. 5, 4.1. And 6, 0. Okay, so 6, 0 is going to be right here. And then I'm going to go ahead and just connect those dots. La, 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 connect the dots. La, la, la. Okay, so there's my curve. And then now it says write down a definite integral that represents area A. So real quick, one thing that I did not do is it told me shading the area A. So I want to shade this region right here. You're gonna color this as best as you can. Shade this. And again, your area can be better than mine, but there you go. All right. So now it says write down a definite integral that represents area A. Okay. So the symbol for integral looks like like that. Okay. Looks like kind of like a curvy S. So we're going to put down where we started. So we're starting from 0 to 6. So 0 to 6. We're going to write down our function next, which is negative x squared over 6 parentheses x minus 6, and we're going to write down what is it that we are finding the integration of with respect to. So with respect to dx, so that is the area under the curve. So that is our definite integral. Okay, so now we have to find the area of A, and our calculator does this perfectly well for us. So we're going to go to our calculator, quit this, quit this. Okay, so now over here, we are going to go ahead and use the integration symbol. Okay, so we're going to hit math, and integration is right here, option number 9. So we're going to press number 9, and conveniently, the calculator opens up a spot for us to put the 0. We're going to go put the 6 at the top. Over here, we're going to go ahead and write down our function, right? So I'm going to type in negative, make sure it's the negative sign. Alpha y equals gives us a fraction bar. So we're going to put x squared in over 6. I'm going to go here and put parentheses x minus 6. And then it's with respect to the variable of x, and you're literally just going to hit enter, and it gives us that the answer is 18. So this is 18 units, square units. So find the area of A. So when I plugged it into the calculator, I got 18 square units. Right? So the calculator gave us that answer. Good. There's question number 1. Okay. Question number 2, very similar, right? Now we just have this function right here, and we are going to go ahead and sketch that curve. So pause the video, go ahead and do this yourself, and come back to check your work. All right, so I went ahead, plugged it in, and I got 0, 0, which I graphed, 1.6, graphed that, 2.8, graphed that. Now the next one that it wants me to graph is 5 halves. Not sure if you know how to do this, but let me just go ahead and show you. You see this table set right here in blue? So you hit second window, and we want to find out 5 halves, so 5 divided by 2. And then now if you go to second table, it gives you the answer. So across from 2.5 is 0. Okay, so I'm going to go here to 2.5 and put 0 right there, and then I'm going to connect my dots. And then I'm going to again shade this region right here. So I have done everything for part A. Okay, so write down the definite integral. So again, I'm going to make my fancy S. I am finding it from 0 to 5 halves, 5 divided by 2, and then my function is negative x squared over 5, parentheses 2x minus 5, and I need to put the dx. So that's my answer for part B, and then now I just need to plug that into my calculator. Okay, so again, I go back over here. So I'm going to find integration, which is math, option number 9, put my 0, go up to the top, 5 halves. Okay, the doot, go here, and then I'm going to put my negative x squared. All right, put my x here, and then hit enter, and I get this answer right here. All right, so this is a weird one to write down, but let's see if it turns into a fraction easily. So hit math, option number 1 is frac. Let's, boom, there's an easier answer, right? So I have, find the area, so it's 125 over, I think it was 96, is that right? Good. And then I'm going to put units squared. Okay, so units squared is the area of this curve, area A. Okay, this next one right here is very similar, so write the integral for the shaded area A. Pause the video, go ahead and try it. All right, so write an integral for the shaded area A. So I know here is my function, right? My function's right here. They tell me, so I'm going to write my symbol. I'm going from 3 through 6, okay? Starting at 3, going to 6, so 3 to 6. I'm going to write down my function because they already gave it to me. X plus 8, close it, put dx. Okay, good. So there's my integral, and now I'm going to take that, plug that into my calculator. Boom, and I got 117 when I plugged all of that in. So this right here, the area of A is 117 units squared, and now they asked us to find the area of B. So I know that, what is it that I know? Okay, here, boom, this is a rectangle. Okay, so let me just highlight that. So here, this is a rectangle, and I know that my length of this rectangle is 6, and my height, not really sure, but my height is going to be whatever number that right there is, right? So if I take 6 and I plug it in for my x, that'll give me my y, which is this right here. So 2 parentheses 6 minus 3 and 6 plus 8 right here. So 2 times 3 times 14. 6 times 14 is equal to 84. So therefore my height right here is 84 units. So to find out the area of my rectangle right here, okay, so I'm going to do 6 times 84. So 6 times 84. I already know, what is it that I know? I know that this right here is 117 already from my answer from part B. This is 117. So to find out the area of B, which is this remaining part, I need to do 6 times 84 minus the 117 that I got from the area of A. So then I just take that, plug that into the calculator, and I get 387 units squared. Okay, so that is the area of section, just section B, just this right there. Okay, there we go. That's question number 3. One more. All right, so the first thing I'm asked to find out is determine the value of K. So I can see that this right here is a coordinate. I don't know what any of the other ones are because I don't know what this is. I can't just assume that it is like half. So I'm going to go ahead and just say, okay, 0, 0 is definitely a point on this line right here. So 0, comma 0. Here's my x, here's my y, and I can plug it in right here. So my y is 0, so I'm plugging in 0. There's an equal sign next. I don't know what my k is, so I leave that alone. My x is also 0, so I'm going to put that 0 there. I should not have closed it. So I do minus 6 squared plus 8. This is something that I can easily solve. Okay, so 0 is equal to 0 minus 6 is negative 6 squared is 36, so that's 36k plus 8. I can do minus 8 from both sides. Cancels out, so I have negative 8 equals 36k. Divide both sides by 36, divide by 36. This cancels out, and I'm left with, this is something I can plug straight into my calculator whenever my calculator feels like working. Work, please. Thank you. All right, quit. Clear. So I have alpha y equals option number 1. I'm putting negative 8 in on top and a 36 on the bottom. So I'm just going to simplify this fraction, and I get that, which I don't want it like that. I want it as a fraction. So negative 2/9. So k is equal to negative 2/9 is the answer for the first part. Okay, good. That just earned me 2 points. Write down an integral that represents the cross-sectional area under the arch shown. So I have my integration, my symbol from 0 through 12. So 0 to 12 because I want to find under the arch. Okay, I'm going to go ahead and put in my function, which now I know that k is equal to negative 2/9. So I'm going to put negative 2 over 9, right? Because that's k, parentheses x minus 6 squared plus 8, and then I'm going to put dx. Okay, So that's all I need to do for part B is just write down the integral that represents the cross section, and then for part C, just plug it into the calculator. All right, in the blink of an eye, I plugged into the calculator and I got 64 as my answer. So find the cross-sectional area. My cross-sectional area is 64. Our units are, I believe, meters. Yep. So this is going to be 64 meters squared because it's area. 64. There we go. Yay! 30 minutes.